So for this problem, we're going to solve the following higher ordered polynomial equation here. So I see that I'm looking at a fourth degree polynomial function here. This function is not factorable, so we need to look at other techniques on how to solve this. Now the first thing that we're going to use to solve this is we're going to use the P over Q process to find our list of possible rational zeros that we can use to then hopefully use synthetic division with to find at least two of our zeros. We have a fourth degree function, right? Fourth degree functions are a lot harder to solve. Some cubics are. Quadratic equations raised to the second power. There's all sorts of techniques at solving quadratic equations. Not as many for third degrees, especially fourth degree. So what we want to do is we want to use synthetic division twice, which is going to take our fourth degree equation, crunch it down to a quadratic. And then we can use other means to solve the quadratic. The way that we do that, take your given equation. We're going to do P over Q. P is your last number, which is a 34. Q is your first number, your leading coefficient, which is a 1. 34 over 1 is just a 34. List all factors of those numbers. All factors of 34. What all multiplies to get 34? Well, let's see. 1 times 34 is 34. 2 times 17 also gets us a 34. And I'm pretty sure that's it. The only thing that multiplies to get a 1 is a 1. So after this, take everything in the numerator, put it over the same denominator. Since our denominator is a 1, this is really just 1 over 1, which is 1. 2 over 1, 17 over 1, 34 over 1. Put a plus or minus sign in front of each one of these, and this is the list of our possible rational zeros. Now this gives us a list of numbers that we can use synthetic division with and play around until we find something that works. Plug in a 1 and do synthetic division, see if it works. Do you get a 0 in that corner? Plug in a negative 1, plug in a positive 2, negative 2, and literally do synthetic division until you find one of these numbers to work. That's the process, okay? So I'm going to start with a 1, and let's test the number 1 and see if it works. So I'm going to put 1 in the box. Drop down your coefficients here. 1 for x to the 4th, negative 6, 33, 6, negative 34. Do synthetic division to see if this works. Drop down the 1. Multiply and add, multiply and add. 1 times 1 is 1. When we add that column, we get negative 5. Negative 5 times 1 is a negative 5. When we add that column, we get a 28. 28 times 1 is a 28. When we add that column, we get a 34. 34 times 1 is 34. And when we add that column, we get a 0. That is what you're looking for. You want a 0 in this bottom right-hand position. As long as you get a 0 there, it means the number that you tested is a solution. So we do know that x is equal to 1. Only 3 more answers to find after this point here. Once you find your first solution, you need to restart the P over Q process all over again, just depending on your problem here. So you're going to take P, which is the last number, and you're going to put it over the first number, which for us, that would be a 34, right? Last number is 34. First number is a 1, which is exactly what we got here in the beginning. This is not always going to happen. It happened for this problem, but sometimes you will get different numbers here, and then you have to make that new list all over again. Every 0 that you find, you got to restart P over Q with the new equation that you're given here. Since we're using the same list, or since we have the same numbers, 34 over 1, we can use the same list. All numbers are game all over again. Just because a positive 1 worked over here doesn't mean it won't work again. You could get 2 positive 1s. Now, I'm going to use a negative 1 for this example here. So I'm going to do synthetic division over here. I'm going to test a negative 1 and use these numbers here. 1, negative 5, 28, 34. And I'm going to do synthetic division all over again, but now testing for negative 1. So let's see, drop down the 1. 1 times negative 1 is negative 1. When we add, we get negative 6. When we multiply, positive 6. When we add, 34. When we multiply, negative 34. And we can see here when we add, we do get a 0. That tells us negative 1 is also a solution here. Now that we've done synthetic division twice, that means this remaining equation that we have here is a quadratic, which means our quadratic equation here, 1 x squared minus 6x plus 34 is equal to 0. This is the quadratic equation that we need to solve, which is going to give us our third and our fourth solutions here. Check to see if it factors. A lot of times it'll factor. If it factors, do that. If it does not factor, throw it in the quadratic formula. Now this particular problem, I do not believe that it factors. X times x gives us x squared, but there are not factors of 34 that add or subtract to get a 6. These are the factors of 34. There's no way to make a 6 out of those, which means we need to use the quadratic equation, which means A is 1, B is negative 6, C is 34, right? Use your coefficients here. Negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, plug A, B, and C into the quadratic equation and simplify. Positive 6 here, plus or minus the square root of. Negative 6 times negative 6 is 36. Minus 4 times 1 times 34, that gives us a 136, I believe. And that's all going to be over 2. When we subtract here, that turns that into 6 plus or minus. 36 minus 136 is negative 100. When you simplify that negative 100, again, I'm going to scooch this along, 6 plus or minus, square root of negative 100 is a 10i. Remember that you want to take that square root of negative 100. Think about it this way. Negative 100 is 100 times negative 1. Square root of 100 is 10. Square root of negative 1 is an I. So we do get 10i there. And that's all going to be over 2. Reduce your fraction. We have 1, 2, 3 terms in our fraction in our problem here. They're all divisible by 2. So let's divide each thing by 2. 6 divided by 2 is a 3. Plus or minus 10 divided by 2 is a 5. Don't forget that I. Over 2 divided by 2 is a 1, so that denominator drops out. Our third and fourth solutions are 3 plus or minus 5i.